Yeah, we're back. Let me take a picture of this, okay? So what's the point of doing this? To see some pattern, alright? You want to observe the behaviorism of numbers. Okay, so okay. And trust me, okay, it will pay off. Okay. Now let's observe behaviorism of these numbers. Right? Okay. Yeah, let's identify some repeating pattern, okay? I mean, yeah, it's not difficult. You're just diagonals, okay? 8, 8, 10, 10, 14, you're 14. It changes the, yeah, it's kind of like geometry of numbers, okay? So it changes this slope. It's getting steeper, right? You have 8, so it's not like y equal x, right? It's y equal 2x, right? You have 16 here, but uh, let's use different color, okay? For steeper slope, numbers repeating itself, okay? Steeper, the uh, slope is 2. Green, slope 1, okay? Slope 2. Ah, slope 1, all right? Slope 2. Slope 1. Slope 2. Yeah, we are doing geometry. We are mixing geometry and number theory, okay? Slope 1, 1, 1, 1. Slope 2, because 1 left, 2 up, right? That's why slope is 2. dy dx, all right? You have slope 3. 1, 1, 2, 3. Okay. We express it with red. Okay. Got stuck in there. Slope 3. Slope 2. It's just coloring, right? Just like children, right? Yeah, coloring. Yeah, we have faith. We are believers. Okay, we believe that we're gonna find something, proof or not. We can still learn something. Okay, so it'll pay off, right? I promise you, because it always has. Yeah, I know, but from experience. Okay, so systematic enumeration method. We don't use calculator. We don't use computer. We just use our bare hands and our bare brains to enumerate numbers in a systematic fashion, very highly organized fashion. Okay, to find some pattern, repeating patterns. Okay, that's what we'll do. I'm connecting the dots. If there's same number repeating, okay, I make connection. That's all there's to it. Okay. Let me get some water. Very labor intensive, right? When I was a PhD candidate, some of my professors told me, "Hey, you gotta do leg work. Yeah, go knock on the doors of all those famous professors, okay, and learn from them, okay, across the campus." Because I studied computational biology, and computer science department and biological biology department is like across the campus, right? A lot of lab work. Good old days. Then later on, I joined the U.S. Army. Okay, so yeah, we do rock run, 50 pounds rucksack. We run with it, on it. Yeah. So I'm no stranger to this leg work. Not really. And I'm a runner. I love running to a fault. Okay. Maybe I run too much. Yeah, as I write down these numbers, yeah, I kind of notice things. The Swazang primes, it tend to have a lot of this. diagonals, Swazang primes. Okay, it's something I just noticed. Right? Yeah, very dense diagonals. Yeah, we can calculate density of these diagonals. Okay, given this one column, how many diagonals are there? You cannot quite read this, right? Don't worry. Okay, you take a break after I'm done doing this. Then I will close this up for you so that you can see. Okay, no problem. Okay, where are we? Mm. Okay. We're almost there, okay? last column. That's that. Good. Oh boy. So we're connecting repeating numbers. All right. That's what we are doing. If it's green, slope is 1. If it's blue, slope is 2. If it's red, slope of this diagonal is 3. Okay. Now let's take 5 minutes break and I'll zoom this up for you so that you can see it. All right. Hopefully I don't accidentally erase all this after all this 1 hour of labor. All right. Very careful. Okay. Uh, yeah, I don't want to cause any glare, so that is too dark, huh? Eh, how about that? Better? That's the best I can do, okay? So, yeah, go ahead, take a screenshot, okay? That's the best I can do, okay? Uh, okay? Yeah, that's the best I can do. So, we take 5. Wow. That was intense, wasn't it? Whew. Now let's analyze this, okay? Observe, right? Let's make some observations. Okay? I mean, it didn't take too long, maybe an hour, 30 minutes, right? Gold box, triangle, okay, so. Okay, let's make some observation. I turn the water so that I take a bath before I go to this bar slash restaurant, okay? Uh, yeah, I'm gonna take a bath soon. So my bathtub is filling with hot water now, alright, so, yeah. Uh, I omitted one. Yeah, slope 3. 1 to the right, 3 upstairs, okay? So, yeah. I forgot another one. Yeah, this Swazang prime pair, they tend to have very dense diagonals. Okay, it's something I noticed. We can make a lot of observation here. Okay, so whenever there's Swazang prime, right, there's this red line here. Okay, and whenever there's twin primes, there's a green line between fourth row and second row. Okay, and whenever there is twin cousins, we have blue line connecting the first and third row. Okay. Okay. Good. And we have this prime gap 8, and then there is no line. Alright, so whatever. Just to remind you, what we are trying to find here is triangle conjecture, right? Does this Goldbach triangle give you complete coverage of even integers all the way up to this next prime minus 1, right? That's what we are trying to prove. And before we prove anything, we want to learn some repeating patterns. Okay? That's the point of all this. Okay? And I'm cold, so I'm gonna turn the heater and check on my water. Okay. Tucking my shirt underneath my sweatpants. All right. Yeah. You made this knot. Okay. What else? You have prime numbers and prime gap numbers, and then you have Goldbach triangle. Okay, which is summation of two prime numbers in this row and column. Okay, so that's our systematic enumeration method. All right. Now, Oh, we forgot to label it, right? Yeah, that's easy. Indexation. This pen is running out. So. Twenty-five prime numbers, okay? You better match. Don't fall. I hope I never have to do this all over again, okay? Hopefully we prove something. Discover something, okay? So. Yeah, it matches. 25 prime numbers. Woo! We're paying a very steep price, okay? Another thing I notice is this. For twin primes, all you have in this twin prime column is just greens and nothing else. Okay? Cousin primes, you have a mixture of green and blue. Okay? In Swazang primes, you have a mixture of red, blue, and green. Something I noticed. Let me check on my water, okay? So I don't want it to overflow, you know. Yeah, it's still good. Okay. Perhaps we have to assume twin prime conjecture is true and cousin prime conjecture is true, Swazang prime conjecture is true. Okay, maybe we need to assume that in order to prove Goldbach's conjecture. Okay, that's not quite proof because in order for that to be proof, we need to prove twin prime conjecture first. Whatever, right? Yeah. Yeah. So when I did this closed form formula, so-called closed form formula for nth prime number, yeah, it's not exactly close. Yeah, it is closed form formula, but I kind of manipulated, expanded mathematical language. Okay, uh, so it's not that great. Okay, so yeah, but we'll go over it at some point. Okay, now yeah, it's kind of cheating, cutting the corner, but not exactly. Okay, whatever. Yeah, just mathematical expression of Eratosthenes' sieve. Okay, that's pretty much all there is. Alright, so anyways. let's get back to this. So if it's between 23 and 29, if we skip 6, can we make up for it? Can we find some gap fillers? Okay. Yeah, like 20, you have 23 and 29, right? So G1 set, let's label it correctly. Well, let me check on my water too. Okay, so yeah, I turned off the water because it's been filled in my bathtub. Gold box set. Can we just do Dido, Dido, Dido? But it doesn't quite save energy, does it? Better just spell it out as G. Just 2 strokes, right? So Dido, Dido, that's 2 strokes too, so. Just for the completeness' sake, we're gonna label this. Okay, barely fits. Yeah, you're observing and witnessing how mathematics is made. Okay, where in this particular method, systematic enumeration, alright? Yeah, you can do it some other ways too, but in my experience, it works, okay, very well, so. But nowadays, mathematicians, they're kind of spoiled, okay? They use computer programming and they use calculator, right? They're kind of spoiled, right? But we are very disciplined people, so we're kind of old school this way, right? I know how to program, okay? Ex computer programmer, so yeah. Right. So first Swazang prime pair 23 and 29. Okay. G1 set downstairs 24 and 30. So we are missing 26, 28. Okay. But no problem. Okay, 26, 28. Just downstairs, downstairs because the fortunately enough for us, the very first prime gap is 2, second prime gap is also 2, okay, so now how about gap 8, the biggest gap we have, 89 and 97, right, becomes 90 and 98, we need 92, 94, 96, okay, yeah, we got lucky this time, but yeah. I mean, this this quadratic growth of this area in this gold box triangle as we increase the horizontal dimension one by one, right? The growth of the area is quadratic, like x squared area. Okay, so the coverage by this gold box triangle, it should be more than enough. I mean, conceptually speaking, right? To cover all the even integers up to next prime number minus 1. Okay? Because it goes a lot more than that. Okay, so that's why I'm guessing the proof of gold box conjecture shouldn't be that difficult. What we gotta prove is you have prime number 47, right? Minus 1 of that, 46. Right here. Okay? And all the even numbers between 2 and 46, we are conjecture, triangle conjecture is that it's all included here, complete coverage of even numbers from 2 to all the way to 46. Okay, so it should not be that difficult to prove. I don't think so. I don't think it would be that difficult. Okay. Now let's think. And let me take a picture of this before I forget. To mark this moment. Good enough. Okay. We look at 23 and 29, okay, so if it skips, if the prime gap is 6, so 24 and 30, right, in G1 set, we are missing 2 of them, alright, so the length of missing link in G1 set is like 6 divided by 2 minus 1, something like that. Okay. For example, 90 and 98, we are missing 3. 92, 94, 96. Okay, so yeah, 8 divided by 2 minus 1. Okay. So that's the length of missing link. Length of missing link in ith prime is equal to, I mean, ahead of ith prime, like between ith prime and I plus first prime is okay. Yeah. That's the length of missing links. Missing link. For example, 19 and 23. Alright. Downstairs it becomes 20 and 24, right? So 22 is missing. Okay? So 23 minus 19, 4, right? 4 divided by 2, 2. 2 minus 1, 1. Okay? Yeah, only one missing link. 22. Okay? We know that much. We need to deal with some bigger number, okay? Because I have whiteboard with bigger primes, okay? So let's grab that and look at it. We're gonna wrap it up very soon, okay? Yeah, I use some different notational convention here, but yeah, we can translate between two different notational conventions. So yeah, 113 and 127, the gap is 14. Okay, pretty big gap. So you know, 100 and 116 and 130. So 118, 120, 124, and 126. Okay, so 122 we cannot find in this column, so we have to look back. And fortunately enough, we have 122 in the penultimate column. Okay, well, previous column. So, but is that always the case though? Does this gold box triangle give us complete continuous coverage of even numbers? We have to think about it. All right. So, and my voice is running out, so we wrap it up. All right. So I go to this restaurant, have nice dinner. I come back and then we'll redo this. Continue. Okay. All right. See you soon. Thank you. Bye.